Picture a world that breaks every rule you were ever taught about planets. A body massive enough to be called a dwarf planet, yet stubbornly refusing to be round. Instead of a smooth sphere, it has the shape of an egg, stretched and flattened, as if some enormous force had squeezed it between two cosmic fingers. And that is only the beginning. This world spins so violently on its own axis that no other object of its size anywhere in the solar system can keep up with it. In just under 4 hours, it completes a full rotation. To put that in perspective, while the Earth takes 24 hours to turn once, this object does the same thing 6 times over. As if that were not strange enough, this flattened world carries 2 small moons in orbit around it, and hidden in the darkness, a ring of dust and frozen debris. For a very long time, we believed rings like that belonged only to the giant planets. We were wrong. This is Haumea, and without any exaggeration, it is the most bizarre dwarf planet humanity has ever catalogued. Haumea lives in a cold and silent place called the Kuiper Belt, a vast field of frozen bodies stretching far beyond the orbit of Neptune. Think of it as a distant, much larger cousin of the asteroid belt that sits between Mars and Jupiter, only colder, darker, and far more remote. Everything out there is buried in ice, and the objects orbiting beyond Neptune carry a name of their own. They are called trans-Neptunian objects, and precisely because they are small, faint, and impossibly far away, these bodies are among the hardest things in all of astronomy to find. Did you notice the world that opened this video, that egg-shaped object drifting in the dark? I have to be honest with you, that image is only an artist's recreation. To this day, no one has photographed Haumea in any real detail, for one simple reason. No spacecraft has ever been sent to visit it up close, unlike Pluto, which received the New Horizons probe back in 2015. Even so, these illustrations are not pure invention. Haumea and Pluto have a great deal in common. They sit at similar distances from the Sun, and they appear to be made of similar materials. So it is reasonable to believe the pictures we have today are not far from the truth. But keep in mind that, in practice, even with our most powerful telescopes aimed directly at it, Haumea remains little more than a tiny point of light crawling across the sky, trailed by 2 even smaller points that are its moons. Finding this object and recording it in our catalogues was an enormous challenge for everything we have already mentioned. On a planetary scale, it is tiny, and it is staggeringly far away. And as if the technical difficulty were not enough, the very story of how Haumea was discovered became one of the most bitter disputes in modern astronomy. A clash that spanned 2 continents, 2 rival teams, accusations that were anything but friendly, and a Hawaiian goddess. Let us go back to the year 2004. At that moment, 2 groups of astronomers, separated by an entire ocean, each claimed to have found the very same object, independently. On one side, in the United States, was a team led by the astronomer Michael Brown, working from the Palomar Observatory. On the other side, in Spain, was a group led by José Luis Ortiz from the Institute of Astrophysics of Andalusia. Brown's team was no group of amateurs. They already had the discovery of Sedna to their name, and soon after, they would put Eris and Makemake on the map as well. Distant worlds that helped reshape everything we understood about the outer solar system. While combing through the Kuiper Belt in search of new frozen bodies, they stumbled upon Haumea. Brown and his team rushed to record the find and proposed naming it after Haumea, the Hawaiian goddess of fertility and childbirth. At almost the same time, on the other side of the Atlantic, Ortiz and his group had observed that same strange point of light in the sky. They realized the object shared striking similarities with what the Americans were describing. The problem was that the Spanish confirmation arrived only after the American announcement had already circulated. And that is when tempers flared. A dispute erupted over who truly held the right to claim the discovery. This argument went far beyond the vanity of signing one's name to a find. What was at stake was the question of who had made the most significant and decisive contribution. After a long stretch of discussions, negotiations, and tense behind-the-scenes maneuvering, the International Astronomical Union reached a careful compromise. The primary credit for the discovery went to Michael Brown's American team. But the organization also publicly acknowledged the importance of the observations made by the Spanish group, highlighting their role in confirming that this world truly existed. Remember the name José Luis Ortiz, because he will return to this story in a way you will not expect. Now let us turn to the numbers that make Haumea so extraordinary. This dwarf planet has an average diameter of roughly 1,600 kilometers, which makes it about 8 times smaller than the Earth. It orbits the Sun at a distance of around 43 astronomical units. And just to give you a sense of scale, the light of our star, traveling at 300,000 kilometers per second, takes about 6 hours to reach it. The path is so long that, by the time sunlight finally arrives out there, half a working day has already passed here on Earth. A single trip around the Sun takes Haumea an astonishing 285 Earth years. In other words, since the moment it was discovered, this world has barely crept along a tiny sliver of its orbit. And that orbit is no well-behaved circle. It is strongly elongated, which means Haumea sometimes drifts far from the Sun and sometimes draws closer. At the nearest point of its journey, it actually comes closer to our star than Pluto itself. But what truly takes your breath away is not its voyage around the Sun. It is the way it spins on its own axis. Haumea completes a full rotation every 3.9 hours. That makes it the fastest spinning object among all bodies larger than 100 kilometers across in the entire solar system. No other large world comes anywhere near that dizzying speed. When astronomers watched Haumea through their telescopes, they noticed something curious. Its brightness rose and fell in a steady rhythm across those same 3.9 hours. The first suspicion was that another body might be orbiting it, periodically blocking part of its light, much like the distant exoplanets we discover when they pass in front of their stars. But after many careful analyses of those variations, the conclusion turned out to be something else entirely, and far more fascinating. The flicker was not coming from another object, it was coming from Haumea's own deformed shape, tumbling at incredible speed. And here we arrive at the strangest part of the whole story. You have probably seen here on the channel that, after Pluto lost its title as a planet, a set of rules was created to define what can and cannot be considered a dwarf planet. One of those requirements is that the body must have enough mass to settle into hydrostatic equilibrium, which is an elegant way of saying it should be round. So an obvious question follows. If Haumea looks like a flattened egg, how on earth can it fit that definition? The answer lies in the very speed at which it spins. While most bodies in hydrostatic equilibrium take on a more or less spherical shape, Haumea rotates so fast that it ends up stretched and flattened, becoming what scientists call a triaxial ellipsoid. That complicated name simply means its 3 main axes have very different lengths. Measurements estimate that Haumea's longest axis reaches about 2,300 kilometers. The middle axis sits near 1,700 kilometers, and the shortest axis is no more than around 1,100 kilometers. 3 completely different measurements, leaving no doubt that we are looking at a stretched out world. So is Haumea in hydrostatic equilibrium or not? The answer is surprising. It is. At its core, hydrostatic equilibrium is the state in which the gravity pulling all the matter toward the center is perfectly balanced by the forces pushing outward. For an object that spins slowly, that balance produces a sphere. But for a body whirling at an absurd speed like Haumea, centrifugal force enters the equation, and the balance ends up producing an elongated shape instead of a round one. In other words, the cosmic egg is exactly the shape physics predicted for a body spinning this fast. Everything is in balance, just in a way that defies our intuition. And there is more. Haumea sits right at the edge. If it spun even slightly faster, the forces would stop balancing, and the dwarf planet would quite literally tear itself apart, possibly splitting into 2 separate pieces. It is believed that this dizzying rotation was triggered by a violent impact in the distant past, the very same event that may have given birth to its moons. And it is those moons we will talk about next. Before we meet the moons, we need to look at the skin of Haumea. The images captured by our telescopes revealed something remarkable. The surface of this world is almost as reflective as fresh snow. It is estimated that around 80% of it is covered in nearly pure crystalline water ice, and a few extra ingredients may help make it shine even brighter. There are hints of possible compounds such as hydrogen cyanide and even inorganic cyanide salts, though these substances are still under investigation. In 2005, two giants of observation, the Gemini and Keck telescopes, managed independently to capture Haumea's spectrum of light. What they found was the signature of large amounts of ice crystals, very similar to those we see on Charon, the largest moon of Pluto. Further analyses, in both visible and infrared light, pointed to a fairly uniform surface made of a nearly equal mix of amorphous and crystalline ice, with a sprinkling of organic compounds thrown in. And here lies a small puzzle. Crystalline ice usually only forms at temperatures above roughly 110 Kelvin. The trouble is that Haumea's surface is far too cold even for that, sitting below 50 Kelvin. Under such frigid conditions, what we would expect to find is amorphous ice, not crystalline ice. So for those crystals to exist, something must have warmed the surface at some point in the dwarf planet's history. It could have been impacts heating the outer layers, or heat rising from deep inside Haumea itself. One way or another, this world holds clues that it was not always the frozen silent block of ice we see today. Here is a fact that tends to surprise people. Dwarf planets are, by definition, smaller than our own moon. And yet, tiny as they are, some of them enjoy the luxury of having moons of their own. That becomes even more curious when you remember that Mercury and Venus, planets far larger than Haumea, have no natural satellites orbiting them at all. For a long time, we assumed Haumea was completely alone out there in the cold. That changed in January 2005, when astronomers at the Keck Observatory spotted a small moon circling the dwarf planet. And this is where one of the most charming parts of the story comes in. At first, Michael Brown's team had nicknamed Haumea Santa, since the object was identified late in the year, right around Christmas. Keeping the joke going, the first moon they found earned the temporary nickname Rudolph, the most famous red-nosed reindeer in the world. But that festive name did not last, and the satellite was eventually given the official name Haumea. Haumea is the largest, the brightest, and the most distant of Haumea's moons, measuring about 320 kilometers across. It follows a nearly circular orbit, completing one lap every 49 days, at a distance of roughly 50,000 kilometers from the dwarf planet. Its infrared signature points to a surface covered almost entirely in nearly pure crystalline ice, and that handed scientists a valuable clue. These moons are most likely fragments of Haumea itself, torn away in a collision millions of years ago. Months later, still in 2005, a second moon appeared. Care to guess its nickname? That is right, another of Santa's reindeer, this time called Blitzen. And just like the first, that name did not stick either. The little moon was renamed Namaka. Curiously, in Hawaiian mythology, Hiaka and Namaka are themselves daughters of the goddess Haumea, so even the names tell a family story. Namaka is the smaller and the closer of the two, completing its orbit in about 18 days, along a slightly more stretched path. Observations made in 2008 showed that Namaka's orbit is tilted by around 13 degrees relative to Hiaka's, and that tilt creates gravitational interactions that disturb the paths of both moons. This is strange because we would expect that, over so much time, tidal forces would have smoothed those orbits out, making them more circular and aligned. The fact that they remain tilted and eccentric suggests that other forces came into play in the past, perhaps encounters with neighboring bodies or turbulent events during the formation of the entire Haumea system. Despite living in one of the most isolated and silent corners of the solar system, Haumea and its moons are not entirely alone. They belong to something larger. They belong to a family. Astronomers call it a collisional family, a group of objects scattered across space, yet sharing physical and orbital traits so similar that they most likely came from a single event. And Haumea's family holds a special distinction. It was the first collisional family ever identified out in the Kuiper Belt. There are several competing theories for how this family came to be. Michael Brown himself, a pioneer in the hunt for dwarf planets, suggested it was born from a direct and violent impact that ripped away much of Haumea's icy shell, scattering the shards across space. Another idea, even more dramatic, proposes that the material flung out in a first collision came together to form a large moon, which was then destroyed in a second impact, scattering the fragments once and for all. A collision born from another collision, like a cosmic chain reaction. But there is a complication in this story. The Kuiper belt of today is remarkably empty, with only a scattering of objects spread across an enormous space. The odds of two pieces colliding out there are minuscule, somewhere below 0.1%. That means Haumea's family probably did not form in the Kuiper belt as we know it now. A group this tightly bound would have been scattered and broken apart by the gravitational chaos unleashed during Neptune's migration billions of years ago, the very process believed to have left the belt as sparse as it is today. The most widely accepted explanation is that this family was born farther inward, in a region between Neptune and the Kuiper belt, at a time when far more material crowded the area and collisions were much more likely. Only later, across the ages, was the whole group pushed outward, until it finally settled into the neighborhood where we find Haumea today. And just when you thought Haumea had run out of surprises, it has one final card to play. Around this deformed dwarf planet lies a ring. For a long time, we believed only the gas giants, Jupiter, Saturn, Uranus, and Neptune, held the privilege of wearing rings. Yet Haumea joined that exclusive club and proved that small worlds can wear that jewel too. We do not see this ring directly, but we know with confidence that it is there, and that was only possible thanks to a fortunate cosmic coincidence called a stellar occultation, which happened in 2017. This event works a little like an eclipse. An object in the solar system passes directly in front of a distant star, from the point of view of someone watching here on Earth, making the star seem to vanish for an instant and reappear moments later. Astronomers love these moments because they let us measure the size and shape of objects with stunning precision. And that was exactly the goal when observing Haumea. But just before and just after the dwarf planet covered the star, scientists noticed small extra dips in its brightness. Those stumbles in the light betrayed the presence of something no one expected, a ring of fragments orbiting Haumea. According to the measurements, this structure is about 70 kilometers wide and forms a circle nearly 4,600 kilometers across, sitting directly over the equator of the dwarf planet. And here, our story comes full circle in the most satisfying way. The team that discovered this ring was led by none other than José Luis Ortiz, the very same Spanish astronomer who once shared the credit for Haumea's discovery with Michael Brown at the start. Several Brazilian researchers also took part in that study, a point of pride for astronomy here at home. The ring is made of dust and rocky particles ranging in size from a grain of sand to blocks several meters across. And there is one elegant detail. It sits in a 3-to-1 resonance with Haumea's rotation, which means each particle in the ring completes one lap every time the dwarf planet spins exactly 3 times on its axis. A perfect, synchronized choreography playing out in the dark. From its egg-like shape to its dizzying spin, from its hidden rings to its small frozen moons, Haumea overturns nearly everything we thought we knew about how a world should be. It stands as living proof that the universe is far more creative and far more diverse than our imagination can ever quite reach. And the most remarkable thing of all is that we managed to learn so much about it without ever sending a single spacecraft to see it up close. Even so, everything we know today paints the portrait of a frozen, stretched out world, brimming with mysteries and wrapped in controversies that earned their place in the history of astronomy. Whether you are someone who loves the cosmos or simply a curious soul who stumbled upon this video, you can feel that Haumea always has one more secret tucked up its sleeve. And who knows what we will reveal as our technology and our understanding of the universe keep advancing. Perhaps one day a mission will finally cross that frozen ocean and capture the first sharp image of this bizarre world. For now, the secrets of Haumea remain locked away in the depths of the solar system. And speaking of well-guarded secrets, I know of another frozen world, just as full of mystery that is well worth your visit. Out there in space lies a small icy moon, capable of firing enormous jets of water into the void from an ocean hidden beneath its crust, a place that may be one of the most promising spots to search for life beyond Earth. Want to know that story? Just click the card here on your screen. Thank you for staying with me all the way to the end. If you enjoyed this content and want to help the channel keep going, leave a like, subscribe, and turn on notifications. Your support makes all the difference in helping more people discover these incredible worlds. See you in the next video.